Dr. Babasaheb Ambedkar Open University.
In last session, we have learned about scheduling criteria and different scheduling algorithms. So, in today's session, our agenda will be to learn about scheduling algorithm, which is a round-robin scheduling algorithm, and another algorithm is priority scheduling algorithm. So, let's start. This scheduling algorithm is known to be simplest, fair, and most widely used scheduling algorithm most suitable for interactive systems. It assigns time slices to each process in equal portion and in circular order, handling all processes without priority. The round-robin scheduling algorithm can also be applied to other scheduling algorithms problems such as data packet scheduling in computer networks. It is similar to first come first served scheduling algorithm, but preemption is added to switch between the processes. So let's understand the process of a round-robin scheduling algorithm. This example here demonstrates how the round-robin scheduling algorithm works with 4 processes P1, P2, P3 and P4, each arriving at time 0 and with a time quantum of 20 milliseconds. The time quantum refers to the amount of time allocated to a process before the operating system switches to another processes. Different processes here and burst times are here, you can see in the diagram as below. Like P1 process has 53 milliseconds and P2 process has 8 milliseconds. Now first understand how round-robin algorithm works. Each process gets a maximum of 20 milliseconds in a cycle, means a time quantum. If a process finishes before 20 milliseconds, it leaves the CPU, otherwise it goes back to off the queue with its remaining burst time. This cycle repeats until all processes are completed. Next, we will understand the execution process. Next, we will understand the execution sequence of this round-robin algorithm. So, P2 and P4 finishes early because their burst time are less than or just over the quantum. P1 and P3 needs multiple turns because their burst times are much longer. So, we also need to calculate the waiting time. So, the waiting time for process is the total time it's in a ready queue waiting for the CPU. As we have seen in the second slide, for P1 for P1 process, it waits from 20 to 68 milliseconds and from 88 to 112 milliseconds. So, waiting time will be the addition of 68 minus 20 and 112 minus 88. So, it will be 72 milliseconds. So, for the process P2, the wait time will be from 0 to 20 milliseconds. So, if we calculate the waiting time, so it will be 20 minus 0. So waiting time will be 20 minus 0 so it will be 20 milliseconds. So for process P3, the wait times will be from 28 to 88 millisecond and from 108 to 125 milliseconds. So the calculation of waiting time will be 20 minus 0 plus 88 minus 48 plus 125 minus 108. So it will be 28 plus 40 plus 70. So the summation of will this value become 85 milliseconds. So if I calculate for process P4, so wait time will be 48 to 108 milliseconds. This round robin scheduling algorithm assures all processes get equal CPU time in each cycles, reducing the chance of starvation. The waiting time for each process is calculated by summing the periods it spends waiting between its turns. This example shows us how longer burst time processes like P1 and P3 are interrelieved and with shorter ones like P1 and P3 are interleaved with shorter ones, and how waiting time accumulates as they wait for the next turn. This approach is fair and responsive, especially for time sharing systems, but it can lead to higher average waiting times if there are many long processes. So next we will understand about priority scheduling and how it works. So a priority scheduling algorithm works by allocating the CPU for processes with highest priority value. Each process is in a job queue is assigned a priority value according to its importance and urgency. The scheduler then allocates CPU to the processes according to their priority level. Priority scheduling works as preemptive as well as non-preemptive policies. The priority of newly arriving process into a ready queue is compared with that of the currently running process. A preemptive priority scheduling algorithm will preempt the CPU if the priority of the newly arrived process is higher than that of the currently running process. Now, a non-preemptive priority scheduling algorithm, on the other hand, will simply put the new process at the head of the ready queue and waits for the running process to give the CPU voluntarily and run the arrived process, and then after it will continue so on. So we will see example of this now. Now let's consider list of processes with arrival time, burst time and priority level is mentioned here in the diagram. So it as you can see at time 0 second only P1 has arrived to the ready queue with the burst time of 3 and priority 2. So what CPU will do? CPU will start P1 and do 1 second job of P1. So at time 1 second, now the processes become 2. P1 that arrive at 0 second and the process P2 arrived at 1 second. Since the priority of process 2 is higher than the process P1 and P2 will ensure that it will get a chance to use the CPU that it will run for 1 second. So at time 2 second what will happen? There are 3 jobs in the CPU. So P1 arrived there. Process P1 that arrived at second 0 and has 2 second job to be done with the priority 2. So P2 that arrived at 1 second and has 1 second job to be done with the priority 1, and process P3 that arrived at second 2 and has a 1 second job to be done with priority level of 3. Here P2 process is with the highest priority level. So what will happen? CPU will do 1 second remaining job of P2, which brings the process to the completion level. So at time 3 second, what will happen? Two processes are left, P1 and P3. So with 2 and 3 priority levels, which assigns to P1 and P3. So what happened next? P1 process will be executed to completion till 5 seconds. So in the next time of occurrence, what will happen? At time 5 seconds, there is only one job left by now. So that is process P3, burst time 1 and priority level will be 3. So CPU will do 1 second job of P3 and it bring to completion. So in today's session we have learned about round robin scheduling algorithm and priority scheduling algorithm. So in next lecture we are going to learn about multi-level queue scheduling and thread scheduling, and another topic is multiple process scheduling. Thank you for your attention, and please subscribe our YouTube channel BAOUGujarat.
स्वाध्यायः परमः